lovely geometry people. Today we're going to work with section 3.3 on proving lines are parallel. So the way we are going to do that is with converses. Yay! And anybody remember what converse was? Converse? Anyone? Yeah, converse switches your hypothesis and your conclusion. So we're going to work with converses. Now, that means we got to go back in our memory bank and talk about our corresponding angles postulate. And what it said is if your lines are parallel, then your corresponding angles are congruent. Well, now let's do a converse. Let's switch it up. If our corresponding angles are congruent, in this case angle 2 and angle 6, then your lines are parallel. Do you see how it does is it takes those two statements, it switched the hypothesis and the conclusion? Awesome. Now, we can take our converse also with our alternate interior angles theorem. So, in this case, our alternate interior angles are going to be angle 4 and angle 6. So, if we know our alternate interior angles are congruent, then we know that line L is parallel to line M. Now let's look at the converse of the alternate exterior angles theorem. So again, it's going to switch my hypothesis and switch my conclusion. So now I'm going to start with my angles. If angle 1 is congruent to angle 7, then line L is parallel to line M. Now, this one's a theorem, which means I can prove it. So, let's look at a proof. Alright, we're given that angle 1 is congruent to angle 7, and we want to prove that line L is parallel to line M. So, let's break down what we know. We know angle 1 is congruent to angle 7, right? We also know that we have some vertical angles that are congruent in here. So that's angle 1 and angle 3 we know are congruent because they are vertical. Alright, and we can also know that angle 5 and angle 7 are congruent because they are vertical. Now, what we know is that we have some corresponding angles also. We know that angle 1 is corresponding to angle 5, and that angle 3 is corresponding to angle 7. Now, these vertical angles, we know they are congruent, but these corresponding angles right now, we do not know that they are congruent because we do not know that our lines are parallel. So, what we need to do is find one pair of these corresponding angles to be congruent. So somehow or another, I've got to get 1 congruent to 5, or I need to get 3 congruent to 7. And so here's our plan. We're going to use a pair of congruent vertical angles to relate either angle 1 or angle 7 to its corresponding angle. So let's see how we do with that. Let's get a good pen. Let's go with blue. So let's start with our 2 columns. When we do a 2-column proof, we need a column for our statements and we need a column for our reasons. Statements are just the things we know. Reasons are why we know them. So our statement that we can start with is that angle 1 is congruent to angle 7. And the reason we know this is that it is given to us. Now again, our goal is to somehow or another get angle 1 to match up to angle 5 or to get angle 7 to match up with angle 3. So how about we go, let's use angle 5. Alright, now the angle 5 right now, the only one I know it's congruent to is angle 7 because those are vertical. So I'm going to use that. I'm going to know that angle 7 is congruent to angle 5. And that, my reason, is because vertical angles are congruent. Now, let's look at my path here. I've got angle 1 is congruent to angle 7, and angle 7 is congruent to angle 5. Well, does that logically make sense that we could bypass 7 and we could go from angle 1 to angle 5? So we can do angle 1 is congruent to angle 5. Now, my reason for that is called my transitive property. Trans, transitive property of congruence. Now, what the transitive, just think of like transit. You're moving. So your transitive property means that you can move from one angle pair to another. So you can go from 1 to 7, and then you can move from 7 to 5. So that means you can go from 1 to 5. That pattern should look really familiar to you. It's just like your law of syllogism that we looked at last chapter, except now we're doing it with congruent angles. Well, so my goal was to make some congruent corresponding angles, and I did right here. I made angle 1 congruent to angle 5, which tells me then that line L is parallel to line M because of the converse of your corresponding angles postulate. So there's a proof that if alternate exterior angles are congruent, then your lines are parallel. Well, we can use this same concept of you doing our converses also with our same side interior angles theorem. And now this is the one that's different. Same side interior angles must be supplementary. So if we know that the measure of angle 3 plus the measure of angle 6 equals 180, then we know that our lines are parallel. So let's look at some pictures here and see, can we figure out which lines are going to be our parallel lines? So we're looking at angle 1 and angle 2. So here's angle 1, here's angle 2. Well, the line that both angles are on is right here, which is line M. So line M is my transversal, which means that the other two lines that make angle 1, so not a straight line, try again. So there's line A and line B are my other two angles, or my other two lines that make angle 1 and angle 2. So those are my parallel lines. Angle A, or line A, is parallel to line B. Now, justify your answer, which means which converse did we use? This is using your converse of your corresponding angles postulate. Nice. So let's look at this one. Another proof. Yeah. Our goal here is to, again, start with our alternate exterior angles and to prove that angle 3 is congruent to angle 5. Well, you know what? This proof is going to start off a lot like our last proof. So let's go with our statements. And reasons. R-E-A-S-O-N-S. Reasons. Statements. Reasons. Alright. Given to us is that angle 1 is congruent to angle 7. Now, if you remember from our last proof, we had to use our pair of vertical angles to get a pair of corresponding angles. So, let's go with, last time we used angle 5. This time let's use angle 3. So my vertical angles are angle 1 and angle 3. So now I can say that angle 1 is congruent to angle 3. And again, it is because vertical angles are congruent. Okay? Now, let's see. Can you find your pattern here on which other angle pairs are congruent? If 1 is congruent to 7 and 1 is congruent to 3, that'll let me know that angle 3 is congruent to angle 7. Again, that is transitive property of congruence. Okay, now since angle 3 and angle 7 are congruent, that lets me know that line L is parallel to line M. And again, that was my converse of my corresponding angles postulate. Now I know these two lines right here are parallel, which means I can use any of my angle pairs now, not just my vertical angles. I can use them all. Well, since these lines are parallel and my goal here is to find out something about angle 3 and angle 5, well, that is one of my angle pairs. So I can know that angle 3 is congruent to angle 5, and that is because of my alternate interior angles theorem. Now, notice I didn't use the converse this time. The converse will let you know that your lines are parallel. Once your lines are parallel, then you know all of your angles are congruent or supplementary based off of your theorems. I hope that makes sense. So, let's look at some algebra type examples, okay? Which is the value of x for which A would be parallel to B? So let's look at these two types of angles. This angle here and this angle here are same side interior. And same side interiors must be supplementary. So I want to add these up to equal 180. So let's simplify. 2x plus 120 equals 180. Now I want to subtract 120 from both sides of my equation, and I'm given that 2x equals 60. So if I divide by 2, that gives me that x is 30. So if x was 30, that would make my two lines parallel. Let's look at one more. What is the value of w for which line C would be parallel to line D? So let's look at where these two angles are. We have 55 and we have 3w minus 2. Well, those are in the same location, so those are corresponding angles, and that means they have to be congruent. So I'd have 55 equals 3w minus 2. So to solve this, I have to add 2, and 55 plus 2 is 57 equals 3w. Now I'm going to divide both sides by 3. Now, to solve for w, let's divide. How many times does 3 go into 5? Well, that's 1 time, and it leaves you with a remainder of 2. So then I need, how many times does 3 go into 27? And that is 9. So if w is 19, then my lines are parallel. Bye, y'all.